When you throw a point particle from a height h, it goes in parabolic trajectory. So let's analyze this trajectory. It will reach a certain highest point from its point of projection, and then it will drop down. The horizontal velocity will remain constant because in horizontal direction there is no net force applied. The net force that is applied is definitely only in the vertical direction. That's why vertical velocity will first decrease, as here shown by the arrows that are decreasing in length, and then the vertical velocity will tend to increase, whereas during the whole motion the horizontal velocity is remaining constant. Let's analyze this motion using equations. Let us assume that the particle was thrown at an angle theta with an initial velocity u. What would be the x component of the initial velocity of the particle? So the x component is represented as u subscript x. It is going to be equal to u cos theta based upon the resolution of vectors, and the y component u subscript y shall be equal to u sin theta. How is the x component changing? We use the two directions that are orthogonal to each other in such a manner that they are independent, meaning the kinematics equations that we'll be applying will be independent of the other direction. So for us, this is the point from where the particle was projected. If we set up a coordinate system over here, this is the y-axis and this is the x-axis. So the x direction motion is going to be independent from the y direction motion. So here Vx, velocity in x direction, is going to be equal to ux plus, no acceleration is there, we are trying to use the formula v is equal to u plus at, which is directly implied from 1D equations of motion, and vy will be equal to uy plus ay into t. Ay is negative g, so here we'll get u sin theta minus gt. Similarly, if we try to analyze what is the x coordinate, the x coordinate will be given as ux into t is equal to u cos theta into t, where t is the time for which this particle is in flight, starting at t equal to 0, where the particle was projected from point O, which we are taking as the origin of our coordinate system. The y coordinate will be given as u sin theta t minus half g t square. The original kinematical formula is s is equal to ut plus half at square. Here the value of a happens to be minus g because there is acceleration due to gravity acting in the negative y direction. So now, based upon these equations, we can find out a certain specific number of things. So the first thing that we would like to find out is the time of flight. So the logic that we'll be using for finding out the time of flight is the fact that at time of flight the height h is going to be transversed in the vertical direction. So basically at time of flight the y coordinate is going to be minus h. So let me represent that. Let's say we are finding time of flight. So what is the logic that we'll be using to find time of flight? We'll be using the fact that y is equal to minus h at time of flight. Okay, so how do we use this? We use the equation y is equal to u sin theta t minus half gt square, and we substitute minus h in the place of y. So minus h is equal to u sin theta g minus half g t square. This is a quadratic equation. So basically you need to solve it using, so since this is a generalized quadratic equation, you need to solve it using the formula method. So if you isolate the square term and the linear term towards one side, what you get is half gt square minus u sine theta t, and let's put the h on the same side of the equation, minus h equal to 0. So you can directly write down the positive time solution, because the negative time corresponds to backward in time motion. This is an insight that the student can have if the student wants to think more about the question. So negative time corresponds to backward time motion. Right now we are not bothered about negative time, so we'll be bothered about only the positive time solution. So the positive time solution t is going to be equal to minus b, that's u sine theta, plus under root b square, that's u square sine square theta, minus 4 ac, that gives us 2gh, plus 2gh upon 2a. 2a, the value of 2a is just g. So this is the time of flight for the given question, and the logic that we have used for time of flight happens to be y is equal to minus h at time of flight, because at time of flight the particle reaches the ground. That means the vertical displacement of the particle is minus h. Why minus? Because the positive direction of the y-axis is chosen to be the upward direction, and hence, since the displacement is in the negative direction, y is equal to minus h will be used for time of flight. The next quantity that we can find out is the range. So for range, the logic that we can use is, range is nothing but x coordinate at time of flight, x at time of flight. So this is a simple logic that can be used. Okay, so what is x? X is u cos theta t, so that is just r is equal to u cos theta into time of flight, so that's u cos theta, and then you can copy this entire expression over here, u sine theta plus under root of u square sine square theta plus 2gh upon g. In many numericals you may have the value of theta as a numerical value and the value of g as a numerical value, which is usually 9.8 meters per second square, sometimes approximated as 10 meters per second square, and the value of u as a numerical value. So it will be easy for you to find r as a number. The third thing that we can find out is the height h, that it goes above the point of projection. So what logic are we going to use, what physical intuition are we going to use for the height h? The physical intuition is simple. We'll be using the physical intuition that vertical velocity becomes 0 when it reaches height h. This is the same physical intuition that we can also use for ground to ground projection. So vertical velocity, that is Vy, becomes 0 at height h when it reaches the highest point. So Vy, the expression of Vy is u sine theta minus gt. So substituting 0 there, we get 0 is equal to u sine theta minus gt. And then this time, let me write it as th, because this is the time in which it is reaching the highest point. Okay, so th is going to be equal to u sine theta upon g. Now we can substitute this time in the expression for y and get the answer, or there is a shorter method that we can follow. The shorter method is generally more convenient and more easy to follow. We can directly use the equation Vy square is equal to uy square plus 2 into minus g into height. So since Vy is going to be 0, we get h is nothing but uy square upon 2g, that is nothing but u square sine square theta upon 2g. Okay, so this th u sin theta upon g is also the time taken to reach the maximum height. So these are the things that we found out for projectile motion that is projected from a height h.